Alright, so we're going to wrap up this lesson, but example 2 needed to be in its own video for some reason. It decided it wanted to play weird. So we're going to find the extrema of the function f of x equals x to the fourth plus 1 over x squared. But we do need to make a little note here. There is a value x can't equal because it would make our denominator 0, and that is 0 itself. We'll still be utilizing it later in the problem, an x equals 0, but for now we have to say x can't be 0. So we're going to start this problem by finding f prime. And since we have a quotient here, we can use the quotient rule, where we take the bottom, the denominator, times the derivative of our numerator, minus our numerator, times the derivative of our denominator, and we divide that by our denominator squared. X squared squared is x to the fourth. So let's clean it up. X squared times 4x cubed is 4x to the fifth. We're going to distribute this minus sign as well as the 2x. So we're going to have minus 2x to the fifth minus 2x over x to the fourth, which can clean up more to 2x to the fifth minus 2x over x to the fourth. And since every term has an x, let's simplify it just a little more. We can divide an x from everything. We're going to get 2x to the fourth minus 2 over x cubed. So that's our derivative. We're going to leave it that way. What we now need to do is we need to figure out what values, what our critical numbers are. So what values would make this equal to 0? And the only way we can do that is by setting our numerator equal to 0. So we're going to go 2x to the fourth minus 2 equals 0. Since I've got two 2's, I'm going to factor that out. I'm going to have 2x to the fourth minus 1 equals 0. If I divide by 2, it's just going to go away. So the 2 kind of doesn't even matter. I do know x to the fourth minus 1 is a difference of squares. So I can factor that to x squared plus 1 times x squared minus 1. And x squared minus 1 is again a difference of squares. So I can factor it further. I'll bring down my x squared plus 1, but x squared minus 1 factors to x plus 1, x minus 1, and I set that to 0. And from this, I figure out what values would make this equal to 0. So I set each factor to 0. There's really no real number that's going to make x squared plus 1 equals 0, so we can ignore that. If we have x plus 1 equals 0, then x would be negative 1. And if we have x minus 1 equals 0, x would be 1. So our critical numbers are negative 1 and positive 1. But because 0 can't be used in the domain, we're going to also say 0 is a critical number. So any number that we can't use, anything that would make our denominator 0, we're going to use that as well. It is a critical number. So now we're going to determine our intervals. So our intervals we're going to say from the negative 1, our interval is going to be from negative infinity to negative 1 as one interval. Another interval will be from negative 1 to 0. We'll have an interval from 0 to 1. And then lastly, we'll have an interval from 1 to infinity. Okay, so we've got our intervals. We now need to determine some test values. So I'm going to just pick some numbers that are in these intervals between negative infinity and negative 1. I'm going to just pick negative 2. Between negative 1 and 0, I'm going to pick negative 1/2. 0 and 1, I'm going to pick positive half. And 1 and infinity, I'm going to pick 2. We're going to do this to figure out the sign of our derivative. So as a reminder, we found that f prime was equal to 2x to the 4th minus 2 over x cubed. So we're going to take and find f prime of each of these values. So f prime of negative 2, f prime of negative 1 half, f prime of positive 1/2, and f prime of 2. We're just going to plug these values into our calculator, or at the very least the negative 2 and the 2. Since they're not fractions, we could use some mental math. So if we go 2 times negative 2 to the 4th minus 2, sorry, that's a little messy, over negative 2 cubed, we're going to get 2 times 16 minus 2 over negative 8, which is going to give us negative 15 over 4. And that is less than 0, which means that is decreasing. Now we're going to use this with the negative 1/2. We're just going to substitute it in. I'm going to just tell you what f prime of negative 1/2 is. It's going to give us 15, which is greater than 0, which means at that interval we are increasing. If we put positive 1/2 in, again, we're just going to substitute it in, but I'm going to tell you that it equals negative 15, which is less than 0, so it's decreasing in that interval. And then we're going to do positive 2. Again, we're just going to plug it in. It ends up equaling 15 over 4, which that is positive, so it's greater than 0, which means we are increasing. So our answer is going to be another statement. But first, what we need to do is take the critical numbers and find out what point they are at. So our critical numbers, if you remember, were negative 1 and positive 1. So we're going to find f of negative 1 and f of 1. So f of negative 1 is going to be negative 1 to the 4th plus 1 over negative 1 squared, which is going to give us 1 plus 1 over 1, which is 2. F of 1 is going to give us 1 to the 4th plus 1 over 1 squared, which is going to 1 plus 1 over 1, which is also 2. So we've got a point at negative 1, 2, and a point at 1, 2. Now, from what we just did in the previous page, since we were going from decreasing to increasing at negative 1, that means f has a minimum at negative 1, 2. And since at 1 we went from decreasing to increasing, we have a maximum at the point 1, 2. That's our answer, and we're done. We found our relative max and our relative min, our extrema. And that's going to wrap up this lesson. I've got more examples, but it's more of the same stuff we've just been doing. If you want to see them, we can look at the textbook in class tomorrow. Bye.